is Jane Conn, and our company is Capital Green Building Group. We do green certifications, Energy Star qualifications, so we kind of cover the gamut if it includes green from LEED to National Association of Home Builders, Florida Green Building Coalition. We do them all. We're just finishing and getting set up. I'm opening the tech type program that I use. It's from the Energy Conservatory, which is Minneapolis. They're kind of the old grandpa of all the equipment. All right, we're going to start the test. So we've got everything covered that's going to get a baseline measurement. And it tells me that it's measuring the baseline pressure, and I see the samplings that it's taking. Now I'm going to remove the fan cover. It says we're depressurizing. Got the manometer turned on. You see this little red dot right here? That was our first point, and it's low on the graph. So that tells me this is a fairly tight house. It's not a big house, but it's a fairly tight house. I've got in ring A, which is kind of like a beginning point ring. It's going to tell me in a few minutes to put in ring B, because you see the fan pressure right here? That's at 31.4. You don't want it to drop below 25. So when it gets down close to 25, the computer will stop the test and will tell me to put in this ring right here. They just constrict the flow of air. We didn't get very far before it told me it wanted ring B, did we? It's a smaller ring, constricts the airflow more, makes the fan work a little bit harder. But you're going to see all these numbers, these two numbers are going to change. But this flow rate is going to continue to go down. I love watching. See all the little points? Those are where the samples are falling. See how your flow rate is coming down? And that's exactly what it's supposed to do. We have now covered the fan. We're through the test, and we're going to get a baseline pressure now. See, it's a pretty straight line. I'm surprised it's that straight with all the wind that we had today. That's a good thing. Came in at 5.77, and we wanted to be between 5.5 and 6.5, so I'd say we did pretty good. We've got enough infiltration and enough leakage so that the house can breathe and be healthy. We have a totally sealed house that people are made of water. When you cook spaghetti or macaroni and cheese for your kids, you put water in the air. When you take a shower, you put water in the air. You need to get rid of that moisture, and that's what bath fans do, and that's what range hood fans do, but nonetheless the house has to be able to breathe. It has to be able to have some fresh air come and go. Alright, the first test I'm going to do is the total duct leakage test, and you'll notice the fan is open, so we don't have the house depressurized. It's an open test. Again, I have a rheostat, I have a manometer. We're going to now do the duct leakage to the outside.
Our Pascal pressure here, we're trying to get that around 25.
We're going to bring the ducts down to 0 and see how much pressure it takes to do that, and that will tell us what the leakage to the outside, not the leakage to the inside of the house. Because if you got something that leaks to the inside of the house, that's okay, because that's where you want the conditioned air. So we want the leakage to the outside, and that's what we're finding out right now. Duct leakage has to be 6% or less to be an Energy Star house. And this house The duct leakage was just a hair over 3%. It is half, basically, of the allowable. So it's a very tight duct system. Your Energy Star qualification really rests upon the commitment by the contractor, your framers, your insulators, and your HVAC contractors. That's where it all, and it starts with the building contractor. They've got to be committed because it's just attention to detail. We got great numbers. Great job. I'm pleased.